Hello, in this video I will do some examples on delivering IV fluids using gravity. So this is under intravenous therapy and we are going over delivering IV fluids using gravity problems. Before I begin, there are a few things that you must know. The first thing you need to know is a drop factor. The drop factor is basically the number of drops in a 1 milliliter of solution IV fluids with gravity, and it could be uh, under a micro. Right. It could be under a macro, it's not micro, macro tubing, which delivers 10, 15, or 20 GH per minute. So what does that GH stands for? It literally means drops. So if you see this GHS, that means drops, that just means drops per, and then per milliliter. And then you can also have a micro drip tubing, which delivers 60 drops per milliliter. Okay, so yeah, drop factor is the number of drops in 1 milliliter of solution of IV fluids with gravity, and it can be a macro drip, which delivers 10, 15, or 20 drops per milliliter, or micro drip tubing, which delivers 60 drops per milliliter. Example one, order is for, let's do an example. So example one says order is for 500 milliliters NS to infuse over 4 hours. You have IV tubing with a drop factor of 10 GHS, 10 drops per milliliters. How many drops GHS or drops per minute should be delivered to the patient? Round to the nearest whole number. So in this problem, we could do is uh we could do dimensional analysis, ratio and proportion, and I think that's it. So what you want is you want GTT, GHS per minute, right? That is your goal. Your final answer has to be, so your goal is to, your final answer should be in JHS per minute. And what we could do is start with dimensional analysis. So what we have, what we got to do is start with what we have. So we have an order for 500 MLS to infuse over 4 hours. So that is a fraction already. So for every 500 milliliters, for every 4 hours, right? And we're just going to multiply it out. And somehow we have to have GHS drops per minute. That's our final answer. So yeah, so we got to convert that hours to minute and then this milliliters per drop. So let's start with the hours. The hours, let's convert that to minutes. So we know in 1 hour, there's 60 minutes, right? Okay. This is the reason I put hour on the top and minutes on the bottom because that's the only way the hours units will disappear. So we're good with the minutes. That's good. And it's on the bottom. And now we have to somehow convert that milliliters into drops per minute. So what do we know? Um, they specifically said you're given 10 drops per milliliters. So you could just leave it as it is right here. 10 JHS per milliliters, 10 drops. So 10 JHS over milliliters. Okay. And as you can see, the let's see what cancels. The milliliters disappears, the hours disappears, and then you're left with GHS on the top, minutes on the bottom. Okay, and then all you got to do is the algebra. So remember, when you're multiplying fractions, you multiply across, never crisscross. So it's 500 times 1 times 10, and then it's 4 times 60 times 1 So that's going to be 500 over 240. And 500 over 240 isn't exactly, it's like a decimal 20.833 GHS per minute. And they say round to the nearest whole number. So zero would be the whole number, next nearest whole number. You look at the neighbor, it is definitely five and beyond. So you round it to 21 GHS per minute. Okay, not too bad, right? So we did dimensional analysis. You could use ratio. We can use ratio and proportion. So let's do that. So yeah, let's do the same problem using ratio and proportion. So if you want to do ratio and proportion, you do have to figure out. So we were given 500 ml over 4 hours, right? The first thing what I would do is figure out how many drops are in 500 milliliters. Okay, so we know 10 drops per 1 milliliter that was given, right? In our problem, it was 10 drops per milliliter. So 10 JHS per 1 milliliter. And then we want to know how many drops, that's our unknown JHS in milliliters. So X and then 500 cross multiply. So it'd be 10 times 500 equals X. So you get X equals 500 GHS. Okay, now we can set up our proportion like this. So we could set it up like this, fraction, and then drops would be GHS per minute, GHS minutes, right? Oh, no, we don't set it like it. We just set it up as a fraction, and we were given 500, oops, what did I put 500? It should be 5,000. 5,000 drops per minute. What was our minute? It was, yeah, we have to convert this 4 hours. Let's do that. I forgot to do that. Let's convert the 4 hours into minutes. So 4 hours, we know how to do that, right? We know that in 1 hour, oops, put hours on the bottom, 1 hour, there's 60 minutes. So 60 times 4 is 240 minutes. Okay. So 5,000 over 240 is going to be 20.833, but if you round it to the nearest whole number, it's 21 GHS per minute. Okay. Okay, let's do example 2. So in example 2, order is for 50 milliliters NS to infuse over 30 minutes using micro drip tubing. How many drops per minute should be delivered to the patient. Round to the nearest whole number. Note, uh, 60 drops per minute for a micro drip. So yeah, that's something you must know. I wrote it in the beginning, but I wrote it again. So yeah, 60 drops per minute for micro drip. So we can do this problem in dimensional, ratio, and that's it. So let's start. I like dimensional analysis because you get all your answers done. So with dimensional, you always start with what you have. What do we know? Order is for 50 milliliters NS to infuse over 30 minutes. So we could say 50 ml per 30 minutes, right? And then we're going to times that. And then we want to get, our goal is to get, um, they're saying how many GS drops per minute. So our goal is to have GHS per minute. That's our final unit. So let's see, the minutes is good. I gotta convert this milliliters to GHS. So we know that we are dealing with micro drip. So it's going to be 60 drops per milliliter, right? For 1 milliliter, it was 60 GHS. Right, that was I think I made a mis no, we're right. This right here, it should have been 60 G drops per milliliter, not minutes. My bad. So this is something you must know. I wrote it in the beginning, and this will give us our final answer in drops per minute, right? As you can see, the milliliters disappear, and then you're left with GHS on the top and minutes on the bottom. So go ahead and multiply across. So it's going to be 50 times 60 over 30. And when you do that, what's 50 times 60? 3,000. And then over 30, and that gives you 100. And then my units are drops per minute. Okay, now let's do the same problem doing ratio proportion. So we were given 50 milliliters over 30 minutes, right? That was given. So what I'm going to do first is convert 50 ml to drops per minute, GHS. So we know that 60, here, let me write it out. 60 JHS drops per minute for 1 milliliter. That's for a micro drip. And we want to know how many drops. So that's our unknown JHS for 50 milliliters. Okay. And you go ahead and cross multiply. So 1 times x is x. And then it's 60 times 50, which is 3,000 drops. Now, we want it per minute. So um, it was, it we were given over 30 minutes, right? And when you simplify that, that's going to be 100 drops per minute. Okay, let's move on to example 3. So order is to infuse 1000 ml NS at 20 drops per minute. You have an IV tubing with a drop factor of 15 drops per milliliters. What is the infusion time in hours for the above order? Round to the nearest tenths. So our goal is to get time in hours, right? They're asking you, what is the infusion time in hours? So our final answer has to be in hours. So we can start with this problem with dimensional analysis and ratio and proportion. So let's start with dimensional analysis. So what we're given, so we were given 1000 milliliters, and our goal is to finally get in hours. And then you have an IV tubing with a drop factor of 15 drops per milliliter. Now I'm going to leave it like that. I'm not going to flip it because that'll get rid of my milliliters. So 15 JHS per milliliter. Okay, so as you can see, the milliliters disappear, and our goal is to get an hour. So now I have to get that drops. Um, what else do they tell us? They tell us that order is to infuse 1000 milliliters and it's at 20 drops per minute. So they tell us, yeah, 20 JHS per minute. Now, should we leave it like that? Or should we flip it? I want to get hours. I think I'm gonna have to flip it because I have to put minutes on the top and I want to get rid of that drops, right? This JHS. So for 1 minute, there's 20 drops per minute, right? That doesn't change our problem. If you flip it, that doesn't change it. And then is this our final answer? Almost there. We have to get it in hours, so I have to get rid of this minute. So I'm going to put minutes on the bottom and hours on the top, right? And we know that for 1 hour, there's 60 minutes. Okay, as you can see, the milliliters disappears, the drops per minute disappears, the minutes disappears, and your final unit is hours. And then all you got to do is multiply across. So 1000 times 15 times 1 times 1. And then on the bottom, it's 1. This is a 1 here times 20 times 60. And when you put it all together, you get 15,000 over 1200. And our units will be hours. That's it. There's no anything above below because it's just hours. What's 15,000 divided by 1200? That's 12.5. And it says round to the nearest 10, so we don't have to round anymore. It comes out exactly as 12.5 hours. Okay. Okay, let's do the same problem using ratio and proportion. So when you're dealing with this, I don't really like it, but before you start your ratio and proportion, you first got to figure out how many drops are in 1000 milliliters. Before we write out our ratio, you're gonna figure out or figure how many drops in 1000 milliliters. Okay, so we have 15 drops per 1 milliliter equals to, we want to know how many drops, that's our unknown, X, and then 4,000 milliliters. Okay, so this was given 15. We know that for one 1 milliliters or 15 drops, we want to know how many drops are there in 1,000, and then cross multiply. So that's going to be X equals 15 times 1,000. And what's 15 times 1,000? 750. I mean, not 700, 15,000. 15 and then three zeros. And then it's going to be drops. Okay. Now, is that our final answer? No, we want it in hours, so we got to get rid of this drops. Uh, oh wait. So we have 15,000 drops over 20 drops, right? That was given. 20 drops per minute. Now, I gotta, you gotta be careful with these, this is a complex fraction. And you have to realize that you have to see that the drops doesn't just automatically disappear. So let's let me show you. Yeah, this is kind of confusing at first, but this is a complex fraction, right? Do you see this right here? This is a complex fraction. Um, if you want, you can rewrite this as, and you'll see why this is going to be in minutes in a bit. So you have 15, this 15,000 drops is your numerator, and then this 20 drops per minute is your denominator. So I can rewrite this as 15,000 drops per 20 drops. And then you have a little slanted line. So you can also rewrite this as a horizontal line as minutes. Now you have a complex fraction, so you can rewrite this as 15,000 GHS divided by 20 GH. Oh, sorry. I'm running out of space. Let me write it out here. Let me write it down here. Sorry. So it's going to be 15,000 drops divided by, see this horizontal line, it's a divide. And then it's going to be 20 J drops per minute. And then what you remember when you're dividing fractions, you can do two things. You can cross multiply or you could change this divide sign into a multiplication. But if you do that, you're gonna have to flip the 20 drops per 1 minute. So this is flipped, so they would be 1 minute on the top and 20 GHS on the bottom. And then on the top, it's gonna be 15, 1, 2, 3. And then wait, this is GHS. Now, this is why the drops per minute disappears, and then you're left with minutes. So this whole thing, whoops. So now when you're multiplying fraction, multiply across. So it's 1,500 over 20, which is 750. And then what is our unit? Minutes. Okay. I wanted to show you that this this is how the drops per minute disappears in your final units is minutes. I just wanted to show you because later on you're going to do more complex fractions and you need to know how to simplify complex fractions. So what I would do is if you have a complex fraction, rewrite it. And yeah, so we have 715 minutes, but is that our answer? No, we want it in hours. So we got to do a little bit more conversion. So we know that for 1 hour, there's going to be 60 minutes. So 750 divided by 60 is 12.5 hours. Okay, let's do the last one. This is not example three, it should be example four. Okay, example four, it says NS is being infused at 30 drops per minute using an IV tubing with a drop factor of 10 drops per milliliter. How many milliliters are infused over 4 hours? How many milliliters are infused over 4 hours? Round to the nearest whole number. So our final answer should be in milliliters, right? They're saying how many milliliters are infused over 4 hours. So that's our goal. So let's start with dimensional analysis. So start with dimensional, you start with what you have. So we started with 30 drops per minute times, and our goal is to get into milliliters. So I have to get rid of this drops, and I probably have to I have to get rid of the drops and I have to get rid of the minutes, right? So what do they tell us? They tell us uh, it was a drop factor of 10 drops per milliliter. Now, should I leave it like that or should I flip it? I should flip it, right? I want to get rid of the drops. The only way to get rid of the drop is put 10 drops on the bottom and then 1 milliliters on the top, right? Um, what else? Like, yeah. And then is this it? Should I do one more conversion? Yes, because our goal is to get only in milliliters. That means I have to get rid of this minute. So what do we know about minutes and hours? Simple. We know that for 1 hour, there's 60 minutes. So I need to put minutes on the top because that's the only way to get rid of the minutes. And then I have to put uh, hours on the bottom. And so for 1 hour, there's 60 minutes. Now we have kind of like have a problem. Our goal is to get into our final answer should be only in milliliters. I still have this hours does not disappear. So we have to get rid of that hours. And they tell us that they're asking you how many milliliters are infused over 4 hours. So you could put 4 hours here and then an invisible one on the bottom. So as you can see, the hours disappears, the minutes disappears, the drops disappears, and then you're just left with milliliters. Okay, and then just multiply across or you put it all in the calculator. I like to just show every work. So on the top, it's going to be 30 times 1 times 60 times 4. And then on the bottom, uh, this is like a 1 times 10 times 1 times 1. And as you can see, our final answer is in milliliters. You multiply across. So what's the, I mean, not, yeah, across. What's the on the numerator? What's 30 times 1 times 60 times 4? That is exactly 7,200 with a calculator. And then on the bottom, what's 1 times 10 times 1 times 1? That's 10. And then what's 7,200 divided by 10? 720 milliliters. And it says round to the nearest whole number, so we are good. We don't have to round anymore. Okay. So that is dimensional analysis. I love dimensional analysis because you could just do it all at once. But if you want to do ratio and proportion, we can do that as well. Okay, so with ratio and proportion, yeah, if you want to do ratio and proportion, you first got to figure out how many minutes in 4 hours. Okay, first figure out how many minutes are in 4 hours. We know that in 4 hours, for 1 hour, there's 60 minutes, right? And that gives you 240 minutes, right? Right? 4 times 60 is 240. 1 times 1 is 1, so that's 240. Then you can set up your proportion. So two fractions. And we want to, our final answer has to be in milliliters. So let's put drops on the top and minutes on the bottom, drops on the top and minutes on the bottom. So we were given for 30 drops for 1 minute, and then we want to know how many drops are there in 240 minutes. Okay. Go and cross multiply. So 1 times x is x, and then it's 30 times 240, and that gives you 7,200 drops. Now I want to, my final answer has to be in milliliters, so we know that for 1 milliliter, there's 10 drops, because that was given, right? Because yes, with a drop factor of 10 drops per 1 milliliter. Well, yeah, we were given 10 drops per milliliter, but you know that you have to flip it because that's the only way to get rid of these drops. So now you multiply across, so 7,200 times 1 is 7,200. And then on the bottom, 1 times 10 is 10. So it is 720 milliliters. Okay, that is my final answer. Okay, I am going to stop here.